Good evening, everyone. Am I audible?
Yes.
Okay, fine. Okay, so we will be looking at problems or any doubts from week 8 today. So maybe let's do it in this way. So maybe we first look at GAs and then PAs and then AQs and then conceptual doubts. The order is any order is fine. So whatever doubts you have, maybe shall we start with GA or maybe PA doubts? So whoever is having doubts from PA, you can start asking your doubts from PA. We can start discussing the doubts from PA. So I have all the questions here. So the screen is visible, right?
Yes, ma'am.
Yes.
Okay, okay. So anyone having doubt
I
in
think
this
somebody's
first?
posted uh,
Yeah.
a question on the chat.
Yeah,
Okay,
ma'am, I have actually posted it down
okay, okay,
in
fine. Let me
chat.
check
Is
it.
it fine?
Yeah, it's fine. But the thing is that if I'm missing it out, please let me know because I may not be able to check the
Okay, ma'am.
chat all the time. Okay, so you are having doubt in this function. All right. So let's look at this function f from r
Ma'am,
to
is this
r.
session recorded, ma'am?
Yes, yes. So f from r to r, f of cx is equal to c times f of x. So we want to check whether this is first of all linear with respect to additivity is there, and then you want to check continuity, and then you also want to check limit x goes to a, f of x exists for all a in r, right? All
Yes,
right.
ma'am.
Okay. So I don't know whether it is a GAP or whatever it is. Okay, let's start. If you can mention it, it will be useful for everyone also. But anyway, yeah.
Ma'am, it's activity 8.1.
Okay, fine. So we are now going to do AQ 8.1. Okay, fine. So the problem is we are having function f from r to r where you are having f of c times of x is equal to c f of x for all x in r and for any c in r, right? So this is the question we are having. So now we want to check whether this satisfies additivity. See here, this is a problem. See, there are problems where you just apply the definition or use the formula, straight away you get the answers, right? But this is not such a question. Here you need to do some tricks to get an understanding of what this function is. Okay, so here you see that you are having f of cx is equal to c times of f of x for all x in r. Okay, so we are trying to see what is this function. Okay, so let's try to do this. Let us see what is what happens to this equation when x is equal to 1. When x is equal to 1, what happens? This becomes f of c, and that is c times of f of 1. And we know that this is true for any c in r, right? So if this is true for any c in r, can I replace this c again with x? Can I do that or not? Yeah,
Yeah, I don't get it.
you don't understand?
No.
Okay, fine. Okay, so what we have done here is, so let x is equal to 1 we have considered. Okay, and we have substituted x is equal to 1 in this first equation. So here x is equal to 1 means f of cx is f of c, and here f of x, so instead of x I'm just putting 1. So the first step is simply substituting x is equal to 1 in the given equation. So is that fine, the first step? Yes.
Yes, ma'am. Yes, ma'am.
Okay, now this is true for any c in r. Okay, so this is true for any c in r. It means what? This is c is just a variable. This means what? C is just a variable. So if we are having a variable in a function, changing the variable, will it change the property of the function? Yes or no?
Yes, ma'am.
It will change.
No, no, not the
Just the
property.
name
It
of
will
the
change the
variable I'm going
value.
to change,
It will
right?
change the value, but it won't change the property.
See, for example, suppose there is a function f of x is equal to x squared, and I am having another function, let's say g of y is equal to y square. Are they different or the same? Are
They're
they
the
different?
same.
They are
They are
same only,
same.
right? See, just the name of the functions and the variables are changed. Same way, here I am saying that instead of the variable c, I will simply replace it with x. Is that fine? Yeah,
Yes,
now you
ma'am.
understand? Okay, fine. So now you can see that I'm having f of x is equal to k times of x for all x in R. And what is this k? K is simply f of 1. Okay, so now do I get the structure of the given function from the information? So first I just had a property of the function. Now I got the structure of the function, right? Is this clear now?
Yes,
Yes.
ma'am.
Okay, so the next thing is that we have to look at the options. So now option 1, they are asking us to check whether f of x plus y is same as f of x plus f of y. What is f of x plus y in this case? It is k times of x plus y, right? And k times of x plus y is kx plus ky. And now again I can replace kx with f of x and ky with f of y. So do we have the first option here? Is it so LHS equal to RHS? So you see that option 1 is correct. Is it clear now? Option
Yes,
1?
ma'am.
Okay.
Yes, ma'am.
Okay. So next we are looking at continuity. So continuity, what do you know about this function kx? This is simply a linear function, right? Yeah?
Yes, ma'am. Y equals to mx.
Yeah. So this is simply a linear function. What do you know about continuity of linear functions? If you have a
They are
line,
always continuous.
yes, so you know that linear functions are always continuous. So what was the second option? Let me just go back and see. So f is not continuous is given, so definitely it is wrong. So we can clearly see that f is continuous. So option uh, 3 was f is continuous on R. That is also clear, right? Because f is a linear function. Clear? Yeah.
Yes, ma'am.
Okay. Next, what is the last option? Limit x goes to a, f of x exists for all a in R, but f is not continuous in R. You know the answer. What's whether it is correct or not? Can you tell me?
It will not be correct.
Yes. Okay. So is this problem clear now?
Yes, ma'am.
Okay. Good. Okay. So the
Ma'am,
last,
ma'am,
yeah.
ma'am, may I ask the next question?
Yes, Meghna.
Ma'am, from activity 8.1, I want to discuss the last question, question number 8.
Question number 8. Okay.
And ma'am, in that I just want to discuss one point which is about the bounded function. I want to know how to find whether the function is bounded or not.
Okay. So let's see what's the question here. So you are in activity 8.1, question number 8. This one. This one you are asking, right?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, fine. So for this question, you are given a function f of x is equal to 1 by e power 1 by x plus 1. And this is true when x not equal to 0, and when x is equal to 0 it is 0. Okay, so now you want, this is fine for you, this is fine for you, only want to know about the boundedness, correct?
Yes, ma'am.
Okay, so before that, if anyone is having doubt in this problem, please let me know so that I don't have to come back to this problem, because there are other options which I can easily discuss while explaining this. Otherwise I can simply explain option 3 alone. Are there anyone who has doubt in other part
Ma'am,
of
can
this
you please
problem?
explain the whole thing?
Okay, fine.
Thank you.
Okay, so for this problem, what is the left hand limit and right hand limit we have to see. So for that, so what happens when x, so for right hand limit we have to consider values where x is positive. So when x is positive, what happens to 1 by x? 1, as x goes to 0, what happens to 1 by x?
Infinity.
Yes, it goes
Infinity,
to
ma'am.
infinity, right? Okay, now if 1 by x goes to infinity, then as x goes to 0, what happens to e power 1 by x?
False, ma'am.
Exponential
One
function, right?
Yeah.
Yeah,
is
that will also,
Infinity.
yeah,
one by infinity.
yeah.
Yeah.
So in that case, the whole denominator e power 1 by x plus 1, this goes to infinity. Okay, so if the denominator goes to infinity, then what happens to 1 by e power 1 by x plus 1?
0.
Yes, this goes to 0 as x goes to 0 plus. So from the positive side, you can see that uh, the limit is going to 0. So what is the right hand limit? The right hand limit is 0. So is
0.
this part clear? Okay. So now we have
But,
to do the similar. Yes. Any
but
question?
if 1 by x tends to like 0, then e to the power 0 is 1, right?
Yes.
So it will be 1 by 2.
Here 1 by x is going to infinity. Here x is going to 0, not infinity. X, as x goes to 0, 1 by x is going to infinity.
Yeah, so the function, well, the value of the function will be 1 by 2, no?
1 by 2. Why?
Yeah, if x is equal to 0.
See here, as x goes to 0, 1 by x goes to infinity. Because of that, e power 1 by x also goes to infinity. Because of that, e power 1 by x plus 1, the whole denominator is going to infinity. So you see that if you have something in the denominator and numerator is a constant and the denominator goes to infinity, then the whole term goes to 0, right?
Oh, okay, got it, ma'am.
Got it? Okay, good.
Yes, ma'am.
Okay, so now we have obtained the right hand limit. Similarly, we can do the left hand limit. So for left hand limit, now when x is less than 0, what happens to 1 by x? As x goes to 0,
Infinity.
Infinity.
infinity, infinity.
Yes, ma'am.
Okay, sure.
Yes, ma'am.
Okay, so this goes to infinity. Then what happens to e power 1 by x? See here, x is less than 0. Are you sure it is infinity? It is a negative
Minus
term.
infinity, right?
Yes, yes, yes. That's what I'm asking again and again. Now x is less than 0. So in that case, as x goes to 0, 1 by x will go to minus infinity. Right? So in that case, e power 1 by x will go to
0.
yes. So this goes to 0. Right? So if this goes to 0, what will happen to e power 1 by x plus 1?
1. Total is 1.
Yes. Okay. So you see that this is going to 1. So if this is going to 1, then you know that the whole term will also go to
Ma'am, in when it is positive, e power 1 by x goes to infinity. When it is negative infinity,
mm.
e power 1 by x should also go to negative infinity,
How
right?
is the graph of exponential function? Can you just quickly check it? What happens when it is going towards minus infinity? Where is the value going? Is it going towards 0 or not?
Oh, yeah.
Okay, fine.
So instead of 0, here it goes to 1. Is it? That's like the horizontal asymptote.
Yes. So here you see that because the denominator is going to 1, so the entire numerator is simply 1, so the entire term is going to 1. So it
Okay.
means the left hand limit is actually 1. Is that clear? Yeah? Fine, right?
Yeah.
Okay, good. So you can see
Yeah.
that the first option is correct. The left hand limit and the right hand limit are not equal. Okay, this left hand limit is 1 and the right hand limit is 0. They are not equal. Okay, option 1 is fine. So option 2 is obviously incorrect. So option 3 is, now we have to look whether f is a bounded function or not. Okay, so to check whether it is a bounded function, already we have done most of the part to understand whether it is bounded or not. Okay, so we already saw that when x is greater than 0, e power 1 by x is going to infinity. So in that case, your f of x is going to 0. And when x is less than 0, e power 1 by x goes to 0. And so you saw f of x is going to 1. Okay. So for positive values, so f of x is going to 0. And negative value, the maximum value f of x is taking is 1. Right? So you always see that your function f of x takes values between 0 and 1 when x is non-zero. And what happens when x is equal to 0? The function is given to be 0.
0.
Right? So now do you see that your function is bounded in R? Yeah?
Yeah.
Okay. So the function is bounded.
It is
So the function is given to be, yes?
bounded means it is in open interval on both sides.
See, bounded means you just need a bound, upper bound and lower bound. So here you can clearly see that mod f of x is less than or equal to 1. Or strictly less than 1 in this case, actually. It does not matter if you put less than or equal to. Yeah, it is less than 1, less than or equal to 1 actually, because you are having 0, yeah, it's fine. So you see this is the upper bound for you here. Okay. So
Yes,
the,
okay.
all the values are belonging to this. Okay, fine. So now whether it is continuous at x is equal to 0 or not, it's already there. If it is
Not continuous.
continuous, yeah, if it is continuous, the left hand limit and right hand limit should be same, right? Here they are not equal, so it is not continuous. So is this problem clear for everyone?
Yes.
Okay, okay, good. So what's the next question we are going to look at? So there is some question in the
Well,
chat.
I've given question 6 in activity 1.
Okay.
Not
Is it this
6,
one?
sorry, 1. 1. 6 is solved 1.
It is this one?
Yes, ma'am.
Are you sure? Because it's just the definition, right?
Yes, ma'am.
Okay, when does a limit exist? What is a see, if a limit exists, it means that both the left hand limit and right hand limit exist and is equal to the limit of the function. Yes or no?
Yes, ma'am.
Yes. So you see that if x goes to a, limit f of x is equal to L, then this means that your left hand limit and right hand limit, both of them are defined and is equal to the same value, L. So option 2 and 4, they are very obvious, yes or no?
Yes, ma'am.
Okay. Now from this, can we say whether f is defined at A or not? Okay. So let me give a
Well, it
very...
should be defined, right?
It's not necessary. Let me give a simple example for you. Okay. So let's say that you are having a function, some function. So let's say you are having some point A and you are having some function like this. What does this mean? What does this
It
circle
means
mean?
that at A, no value of FA in like
Yes.
exists.
So it means f is not defined at A. Correct?
Yes, ma'am.
Okay. So now let us call this value here as B. Okay. Now you can see that both from the right side and the left side. So if you are approaching A from the right, from the left or from the right, function f is approaching the same value b, right? So you can see that limit x goes to a, f of, so a minus, and limit x goes to a plus, f of x, both are the same b, right? So this means that limit x goes to a, f of x is equal to, is that correct from the given graph? Is this correct?
Yes,
Yeah.
ma'am.
Okay, so now you can see that this limit is there, left hand limit and right hand limit are equal, but f is not defined at a. Is that fine?
Yes, ma'am.
Okay, so if it is not defined, so this is also not possible, this is also not possible, right?
No, why is option 5 not possible?
If it is not even defined at a, then how it can be continuous? See, for continuity, the very first point is f should be defined at a. That is the first condition. F of a exists. So it means the value of f at a is defined. That is the first criteria for continuity, right?
Okay, ma'am.
Ma'am, just a question to understand this whole theory.
Yeah.
So even if it is not continuous at A, there is a limit at A, right?
Yes, yes,
No, that's how this theory works.
exactly.
And can you just scroll down a little bit, ma'am? I can't see the graph. The little scale. So the limit is B for
Yes.
a f that is not defined at x equal to A.
Exactly.
Okay.
Okay, that is why for continuity we have 3 points. First of all, your function should be defined at a, and the limit should exist, and the limit should be equal to the value of the value of the function at that point. That's why we are having three different points, not just one point, the final point. We are having all the points here. Okay, so it is possible.
So even if the function is not defined at A, there can be a limit on A on that function, right?
Exactly, that's what is this example.
Okay.
But it is not differentiable if it is not defined at A.
It is, see, it is not defined means it cannot be
It is not
continuous, it
continuous, so
cannot be
it cannot be
differential, it cannot be,
differentiable.
you cannot talk about anything if it is not defined at a. Continuity and differentiability are something which we cannot even talk about.
Okay.
Okay, fine. Okay, so what is the next problem we are going to look
Ma'am, I
into?
have a doubt in second question on the
Oh,
same activity.
okay, yes, what's your doubt?
I have doubt on the old problem. Can you explain it?
See, if you are having doubt in this problem, it means you are lacking the understanding of how to find the left hand and right hand limits, because this problem is about that only, I guess, right? Yeah, left hand limit, right hand limit, and also continuity. Okay, see, if you are listening to this particular explanation properly, you will be able to solve any kind of problem like this. Okay, so listen carefully. Okay, so let's say you are at this point, x is equal to 2, right? So what is this particular point? 2 comma 10, right? So now when I am approaching 2 from the left hand side, so this means limit x goes to 2 from the negative side of 2, from the left hand side of 2, of f of x. So where is the function going? So the function is going towards which point? Yeah, what is the value of the function towards which it is moving the graph?
10.
10. Okay, now the same thing, suppose I want to move from the right. So I want to look at the value of the function when I am moving from the right. So when I am approaching from the right, where is the function going? Towards which point?
2.
2.
2.
So you see that this is the right hand limit. Okay, so now is the left hand limit and right hand limit equal? Are they equal? No, obviously they are not equal. If they are not equal, then you can say that f is not
Discontinuous.
continuous at x is equal to 2, right? Clear? So now if you have understood this, the other thing also should be very clear for you. Now can you try it by yourself? What is the left hand limit when you approach x from the left hand side of 4? So limit x goes to 4 minus f of x. Where is the function approaching? Can you see it and tell me?
10.
10, again 10. So now what about the right hand limit of the function when you approach x
4.
to 4? So
4.
it is approaching 4. Again you see they are not equal, so f is not continuous. Okay.
Okay.
At x is equal to 4. See, usually this is how, like a very rough idea of continuity, if you want to say. If you are able to draw the graph of the function continuously without taking the pen from the paper at that point, then it means the function is continuous. But when you are crossing x is equal to 2, are you able to draw the function without taking your pen from the paper?
No, ma'am.
So it means there is a discontinuity. The same way at 4, right? So you see you are having discontinuity. This is a very vague way, but yeah, this is easy to visualize at least. Okay, so you see that in these places f is not continuous. Okay, and also we have seen about the limits. So now it is very easy to check these conditions. Limit x goes to 2 minus f of x is 10, 2 plus is 2, x goes to 4 minus is 10, so this is incorrect. 4 plus is 4, this is correct. F is continuous at x is equal to 2, that is incorrect. And f is continuous at x is equal to 6. Okay, at x is equal to 6, you have a very nice function. There is no discontinuity here, right? Continuous in the obvious sense, if you see, it's just going continuously. There is no cut or anything happening here, right? So I don't know exactly which number it is pointing to. So approximately, if you want to have some limit also, you can check. So it must be something like 2.3 or something approximately. Okay, so or 2.8 maybe, 2.8 or something. Okay, so you see that limit x goes to 6, f of x is equal to approximately, we are just having it, okay, 2.8, and that is actually f of 6. Okay, so the left hand limit, right hand limit, both are approaching the same point. Okay, and hence you see that it is continuous. Is this question clear now? Yeah.
Yes,
Yes.
ma'am.
Okay, good. Okay, so what's the next
Ma'am,
question?
ma'am, can
Yes.
we take question number 2 from 8.2 activity?
Okay. This one?
Yes, ma'am.
Okay. Fine. So which of the following options showing stepwise solution to check whether a function is differentiable or not are true? Okay. Fine. So this is a formula for verifying the differentiability that you all know, right? Limit h goes to
Yes,
0, f
ma'am.
of a plus h minus f of a by h. So that is a
Yes,
formula
ma'am.
used everywhere. Okay. So first function is f of x is equal to c. So if f of x is equal to c, what is f of a plus h? Instead of x, you have a plus h. But here on the right hand side, it has nothing to do with x. So what
Okay,
should
it
be
should
f
be
of
C, only C.
only c, right? And what is f of a then?
C,
C. So the numerator is c minus c. So it should be actually 0, right?
0, 0, huh?
So this should be
Should,
0, but it is given as h. That's why it's incorrect.
okay, ma'am, okay.
Okay, so the next one, you see that f of x is equal to x minus c. In this case, what is f of a plus h? Instead of x, you need to put
A,
a plus h.
A
Yeah,
plus H minus C,
yes. And f of a is
A minus C.
a minus c. So a plus h minus c minus a minus c. So this means what? Your A and A are going to get cancelled. Your C and C are going to get cancelled. And you will have just H remaining. So you have H by H, so which is 1. So
Ma'am,
everything
here,
is fine.
ma'am, here H by H we can cancel. So
Yes,
only limit H tends to 0, 1 will be left. That's why answer is 1.
yes.
Oh, okay.
Okay, fine. So
Yes, ma'am.
this is fine now. So let's look at option 3. Option 3, f of x is equal to x squared. So what is f of a plus h then?
A plus H square.
A plus h the whole square. And f of a is a square.
A square.
So now a plus h whole square is a square plus 2ah plus h square. Right? So when I'm going to subtract this a square, what will be remaining? 2ah plus h square. So this term is correct. Yes or no?
Yes, ma'am.
Okay. So the problem is what happens after this. Okay. So
Yes, ma'am.
2ah plus h square by h. So I can take h commonly. So you have h times of 2a plus h by h. So h and h
Okay, okay.
cancel out and you have 2a plus h. Now when you apply h goes to 0, what will happen? You will
2A
be left
will be
with,
left.
yes. So you are given it as 0. So this is incorrect. Got it?
Okay, okay.
Okay. So option 4. Check whether f of x is equal to e power x is differentiable at a. So f of x is equal to e power x. So f of a plus h is e power a plus h and f of a is e power a. Right? Now what is done? You are taking e power a commonly from both the terms. So what is remaining? E power h minus 1. Okay, and you see that e power a is just a number because a is a constant, so this is just a constant, so you can take it out of the limit. Okay, because this is a constant, and then
Yes,
you
ma'am.
are left with e power h minus 1 by h. Okay, now what happens when you apply h goes to 0? The numerator becomes e power h, first of all, becomes
1.
Okay, okay.
1.
1.
So 1 minus 1 will become
0.
0. So in the denominator also h is going to 0. So what is this kind of a form called?
0 by 0 form.
0
Yeah,
by 0.
indeterminate form, right? So we are having an indeterminate form. So if we are having an indeterminate form, then what is the rule we need to apply?
That L,
L'Hopital.
Yeah, L'Hopital we will apply. If you are applying L'Hopital, then you will see that the numerator, if you differentiate, you will have, so this part is equal to e power h minus 1. The derivative of minus 1 will be 0 and the denominator h is simply 1. So now limit h goes to 0. What is this? What is e power h going to 0?
1 only.
1. That's why e power a into 1 is there, and which is e power a. Is that fine? Yeah?
Yes, ma'am. Yes, ma'am. Thank you,
Well,
ma'am.
just a small doubt.
Yes.
If limit x tends to 0,
Hmm.
what will be the value of limit x tends to 0, x by tan inverse x?
X by tan inverse x.
Yes, but
Okay, so we need to do that separately. So is it involved in some problem?
yeah, it was actually involved in activity 8.1 question 7, I guess. It was x by
8.1.
tan inverse 2x.
8.1.
8.1, yes, ma'am.
This one.
Yes, ma'am, this one.
Okay. So this problem here, we want to see what is the, we want to check the continuity of the function. All right. So if, to check the continuity of the function, okay, it is given that the function is continuous and we want to find the value of a and b. So
Yes,
in that case, if f is continuous, then we know that the left hand limit and right hand limit exists. So you are trying to find the limit of this function. All right.
yes,
Okay. So limit. So x greater than 0. So this is the right hand limit. F of x is limit x goes to 0, x by tan inverse of 2x. Okay, so now here, see, there are few formulas for us, like it's not exactly formula, of course there is some explanation behind that also, like we have limit x goes to 0 sine x by x is, what is this value?
1.
1.
1.
Same way, limit x goes to 0 tan inverse of x by x is
1.
1.
so 1.
1.
So now in place of x, if I am having ax, both are ax, then it should be again 1 only. It should be 1 only, because you can treat this ax now as y, right? Yeah.
Yes, ma'am.
So if you are having something like this, you put y is equal to ax. Now x goes to 0 means y also goes to 0, right? So you can replace this with limit y goes to 0 tan inverse of y by y. Now you know the tan inverse of y by y goes to 0 is 1. Okay, so we are going to use that here. So if we are using this here, how can we use this? Any idea? What is that we...
We didn't know
Ma'am,
the
we
Ma'am,
second
multiply with
formula.
2 and divide with 2 at the same time.
Sorry, what?
Ma'am, I
Ma'am, we
said that
multiply x with 2 and the denominator with 2 at the same time, so we will get the limit as half.
Okay, so the one, someone is saying that you don't know this formula. So do you know this formula?
yeah, I know the upper one.
Okay, so how did you get that?
From the lectures, ma'am.
Okay,
Yeah, by
so
applying sandwich
that is
theorem.
fine. I'm asking, do you know what is the logic behind it?
By applying sandwich
No.
theorem.
I mean, it was taught in lecture 1.
Ma'am,
Okay.
this comes from expansion of sin x.
Okay, so similarly, you can do this. See, first of all, I would suggest, because this is something very often used, sin x by x. This is not very frequently used, but sin x by x is something very frequently used. So look at how you obtain this one first. So if you understand this one, everything else is something very similar to that one. Okay, so I will suggest
Okay,
you
ma'am.
to first look at how you got this. Same way you can get this also. So these are some formulas only. You have to just look at it and like practice. When you practice, you will get to know these formulas. Okay,
Okay, ma'am.
fine. Okay, so someone suggested that we multiply 2 here and 2 here, multiply and divide 2. So you are having 1 by 2 times of limit x goes to 0, or we can replace the x by y. So y by tan inverse of y. So we know that tan inverse of y by y goes to 1. So what happens to the reciprocal of it? The reciprocal should
It
also
will
go to
also go to 1.
1. So the answer is 1 by 2. Is that fine? Yeah?
Ma'am,
Yes,
ma'am,
ma'am.
so can we say, like, use the word reciprocal? So if we
Mm-hmm.
have somehow reached like limit x goes to 0, x upon sin x, will that also go to 1?
Yes.
Okay, okay.
Okay. See, it's simply rewriting only. So you can rewrite this as, so y by tan inverse of y means you are trying to rewrite this in terms of this. Okay. 1
Yes,
by
ma'am.
tan inverse of y by y, which is same as this. Okay.
Okay, ma'am.
Fine. Fine. Okay. What's the next question we are going to look at?
I have note from activity 8.3, 8th question.
8.3, 8th question. Is it this one?
Yeah, yes.
Okay. Okay, if f of x plus y is f of x into f of y. Okay. Okay, so this is something very similar to the very first problem we did today. Here we are having f of x plus y is equal to f of x into f of y. Okay, let's see what kind of a trick we can apply. F of
Is
9.
it a linear function?
Linear, linearity we cannot tell from this, right? How can we tell linearity from this? Linearity means we should have something like ax plus b. That we don't know it, right? So you have to apply some trick like making one of the values 0 and then looking at what's happening. Okay, so maybe we'll try making the y value 0 and see what happens, so that we will get an idea of what f of x. So let's take,
Excuse me, ma'am.
yes,
Ma'am, like in class 12, we have put some 5 functional equations, so it resembles with it. So can't we assume f of x equals to e to the power x?
see, yes, there is some logic behind what is that, but here we have some other way of doing that also. See, whenever you are assuming something, there is a risk that it is wrong. If you are very sure about what is the technique or what is the reason behind it clearly, definitely you can go for it. But if you are just doing with assumptions or samples, then please don't go with it. We may not end up with the correct answer. Okay, yeah, what
Okay,
you're
ma'am.
saying is having some logic behind it, but let's not use that. Okay, so here let y is equal to 0. If I am taking, then I have f of x is equal to f of x into f of 0. So what does this mean?
Means
What
f
does
of
this
0
say?
should be 1.
1, right? F of 0 should be 1. Okay, so now we have got the value of f of 0 to be 1. So with this, what can we do? What can we do with f of 0 1? Let's see again. Here you are having the derivative of f at 0 and 9 we are asked to find. Okay, so let's try to find what is f dash of a according to the limit formula. What is the limit formula? Can anyone tell the limit formula? Limit?
Of x plus
Limit
h.
h tend to 0, f of a plus h minus
Yes,
f of a
good,
upon h.
very good. Okay, now for this particular problem, what will happen to f of a plus h?
F of
F
a
of A
into
into
f
F
of
of
h.
H.
I have limit. So limit h goes to 0, f of a into f of h minus f of a by h. Okay, so now I can take f of a commonly and it is simply a number, so I can bring it out of the limit. So it is limit h goes to 0, f of h minus 1 by h. Now can someone identify what is this part?
Ma'am, it's looking similar to
Seems like some formula, ma'am, like
This
F
tan
dash
minus
0.
1 by.
Yes, see, this is where we are going to use this part. So f of a into limit h goes to 0, f of h minus, instead of 1 I can replace it with f of 0 now by h. Now can you tell exactly what is this? F of a
Ma'am,
into,
just we have put a equals to 0. It's
It
a
will be
f
1.
dash 0. F dash 0.
okay, and do we know what is f dash 0?
4.
4.
And is this a, any a in r? This is true for any a in r, right? Yeah, so can I
yes.
replace a with x then?
ma'am, I've lost the track. I could understand that FA limit h tends to 0, FH minus F0
Hmm.
by h. This much I could understand, ma'am. After that, what
Okay.
have we done?
Okay, just hold on 1 minute. I just felt that it's confusing to have that one here. Okay, fine. So what is f dash of 0? According to the formula, this formula, it is limit
4,
h goes to
4
0,
is
f of h minus f of a by h. It's the exact same term we are having here. So here f of a is actually 0, So this is the exact same term we are having here. So I'm replacing this with f dash of 0. Is that fine now?
Yes, ma'am.
Okay. So now can I replace a with any number?
Yes, ma'am.
Okay. So now I want to find what is f dash of 9. So f dash of 9 is f of 9 into 4. Now what is f of 9 for me?
6.
6. So what is 6 into 4?
24.
Okay, is this clear?
So is this
Yes.
logic can be done for all the sums, right? For the all type of.
So this can be done for what?
This can be done for all similar types, right?
Yes, yes. Any similar question? I guess there was one in GA also, if I remember.
So can we
yes.
also
Ma'am.
assign x equal to 0 in this case?
Yes, that does not matter. They are just variables. Yes. Anyway,
Okay.
finally you will get f of 0 equal to 1. It does not matter whether you put x is equal to 0 or y equal to 0.
Okay.
Okay. Okay. So if this question is fine for everyone, what is the next question?
No,
Yes.
ma'am, just the last, second last line, the
Mhm.
second last line that you have. Yeah, how did we arrive at that?
See, this is what exactly I was telling. So this part is nothing but f dash of 0. Okay, this part is nothing but f dash of 0. If you just apply the formula a equal to 0, you will get that this is nothing but f dash of 0. And already we have that f dash of 0 is given to be 4. So it is just replacing f dash of 0.
Okay.
Got it? Yeah. All right. Okay. So
Can
what's
you
the
tell me
next?
once more that not this part, f of x is equal to f
Hmm.
of x plus, sorry, f of x is equal to f of x of f of 0. Can you teach that part alone? Let y is equal to 0, that part alone, first part alone.
See, I am simply replacing y with 0. If I am replacing y with 0, I will get f of x is equal to f of x into f of 0. Right? Now this means what? Here I have f of x on both sides. Right? So this is a function and this is a non-zero function, you can see. So you cannot have f of x 0 on both sides. So I am assuming that this is non-zero. If I am assuming this to be non-zero, I can simply cancel out and get that f of 0 equal to 1. Is that fine?
Yes, ma'am.
Okay, good. Okay, what's the next question?
Ma'am, activity 1, question 5.
Activity 1, question 5. This one? Are you asking
Ma'am,
this one?
activity 1.
Yes, this is activity 1.
I think he meant activity 2.
Yes, ma'am, this is the question.
This one, right? Okay.
Yes, ma'am.
Okay, so these kind of questions and all, like there exist function. So for these and all, you have to be a little, like you have to imagine, or sometimes you have to apply logic also, but sometimes you have to like think about graphs or something like that. Okay, fine. Let's see what is the what is that we need to exactly use. First option is there exists a continuous function f from 1 comma 5 to 1 comma 7 such that f of 3 is equal to pi. Oh, this is very easy. First option is at least very easy. Can someone say what some continuous function you can give
Yeah, it's
for
true.
which f of 3 equal to pi?
Yes, ma'am, it's
Yes.
true.
True.
What is that function?
Ma'am, fx equal to pi, we can take a constant function.
Exactly. You can define f of x is equal to pi for all x in 1 comma 5. So in that way you see that this is a continuous function, right? All values, constant functions are usually continuous. It is simply a horizontal line, right? So it is continuous. Okay, so option 1 is very easy. What about option 2?
Ma'am,
Yes.
what does the option 1 mean by saying that f from 1 comma 5 to 1 comma 7? I mean,
So this is
X
the
belongs
domain.
to.
This is the domain. This is the codomain for F.
Isn't that the range?
Range is different from codomain. Range is a subset of codomain, right? So for example, if for this specific function, what is the range? Can you tell? Range of F is
Pi.
3.
Pi. Okay, pi is the range, and pi, what is the value of pi? Approximately.
3.14.
And you see that the value lies
It lies
inside the
between 1
codomain,
to 7.
right? So you see that pi belongs to this interval.
Ma'am, one small doubt in this case, ma'am.
Yes.
Where pi is it's not a natural number, right? It's a rational number. So if it's a fractional number.
Yes.
Ma'am, if in this case is just given that codomain lies in under nature, it's a subset of natural number, means this is a continuous function.
No, see here 1,7 does not mean natural number. It is representing all x in R according to the definition of a closed interval. It is set of all x in R such that 1 less equal to x less equal to 7.
Yes, ma'am. Ma'am, my doubt is in this case, instead of R, if they just mention of n natural numbers, means is this a continuous?
If it is n, so how will you first of all pi belong to that codomain?
Yes, ma'am. It's it's not from a codomain. Now, then it will
Yes,
be a non-continuous function.
Whatever you are defining in the range should be in the codomain. It means the function is not even defined at all.
Yes, ma'am.
All right. So option 1, I hope it is clear. So option 2, shall we move to option 2? Option 2
It's
says
a
that it exists.
continuous, ma'am.
Okay, let's first see. Here there exists a continuous function f from 1, 10 to 2, 8 such that f of 1 is equal to 3 and f of 10 equal to 5. So okay, so this is a little bit involved. How many of you were able to come up with a continuous function satisfying this condition?
Yes, ma'am, we can find.
Yes. How do you find?
Ma'am, we can take 1.1, 3 and another point 10, 5.
Okay.
And we can make a straight line.
Exactly. Okay. See, what you are doing is actually, this is what you say, that you try to visualize it with graph. Very good. This is how you have to do. This is the first step. But going further, how do you find the line? What is the equation of the line?
Ma'am, 2-point form.
Yes. See, what you said is enough to say that this option is correct. But just I'm asking whether did you think about how do you get the line?
Yes, ma'am, using 2-point formula, we can use y minus y naught equal to
Yes.
y2 minus y naught upon x2 minus x naught,
Okay.
x minus x naught.
Okay. Yes. Very good. Just you need to use that formula. Very good. So for those who did not get what she mentioned, so suppose you want to have a function f from x0 comma x1 to y0 comma y1. So in our case, x0 and x1, what are our x0 and x1? x0 is 1, x1 is 10. And what is y0, y1? 3 and 5. Okay. If you want a function, okay, such that you want f of x0 is equal to y0, f of x1 equal to y1, then what you need to do? You need to define f of x in this way: y0 plus y1 minus y0, y0 by x1 minus x0 into x minus x0. So you can clearly see that f of x0 is, if you put x0 here, this term will become 0, so y0, and f of x1 means, so this will become x1, this and this will get cancelled out, and then you will have simply y1. Okay, So, and all the other values will lie between y0 and y1. Okay, very good. So these are based on intuitions, right? Okay, what about option 3? There exists a
True, sin x.
okay, very good. Non-constant continuous function f from R to R which is bounded, sin x, cos x. Yeah, these are very simple examples you can think about. Okay. What about option 4? There exists an unbounded continuous function from 2, 3 to R. Open 2, 3 to R.
Ma'am, 10x.
Sorry, what?
10x.
Tan x. Okay. So for tan x, how do you know that between 2 and 3 there is no discontinuity? And why it is unbounded between this interval 2, 3? What is tan 2? Is it defined? What is tan 3? Is it defined? Why it is unbounded?
Ma'am, can't we treat pi as 3.14?
Sorry, what?
Considering pi as 3.14, or we should take 180 only.
See, when you are doing this tan x, sin x and all, you should be careful whether you are using radians or degrees. Okay. So when you are using tan x here, you have to be a bit careful. Okay, think about tan x once again. Okay, can you come up with something very simple? You want
Ma'am, 1 upon
yes,
1 upon x minus maybe we can take 2.
very good.
1
Very
upon
good.
x.
Yes, this is something very simple. Yes, yes, just like 1 minus x. Here, since we are having open 2, then 1 by x minus 2 will work. Yeah, very good. So here for this you can think about 1 by x minus 2. You can see that as x goes to 2, the function blows up, so it is unbounded. Yeah, and it is also continuous within this given interval. Right, very good. Okay, so all these options are fine. So this question is done. So if this is fine for everyone, what is the next question we are going to look at?
Ma'am, in a practice assignment 6 onwards, I think, ma'am, can we go through one by one all the questions?
6 onwards. So this one?
Yes, ma'am.
Okay, so maybe I should put some values here. Can someone give some values, whatever you are looking in your portal? Tell some values, otherwise it will not be good. So x is equal to, what is the value you are seeing? Tell me.
Ma'am, 1 minute, my portal is opening.
Yeah.
Ma'am, somehow my portal is not getting open. Can somebody else help read question number 6 from practice assignment?
Okay, no issues. I can just assign some random values also.
We have a word problem.
Okay, I will just assign some random values. Okay, so let x is equal to k is equal to 2 and p is equal to maybe 3 and passes through the point maybe minus 1 comma 4. Okay, just some random values I am taking. Okay, what will be the value of f dash of t? Okay, fine. So it is first of all given to us that f is differentiable at x is equal to 2. Right? So if f is differentiable at x is equal to 2, we know that first of all f dash of 2 is defined. Right? So if f dash of 2 is defined, so how can we look? So the tangent line to the curve represented by the function at the point k comma p passes through the point minus 1 comma 4. So how do you find f dash of 2? So what is the other interpretation for the derivative of a function at a point. Other interpretation based on tangent. The derivative of a function at a point, how do you interpret based on tangent?
Slope of the tangent.
Exactly, exactly. So f dash of 2 is the slope of the tangent at x is equal to 2. Right? Tangent of this function at x is equal to 2. So how do you find the slope of a tangent line which is passing through 2 points? You are given 2 points on a line. How do you find the slope of the tangent or slope of the line?
2-point formula.
Yes. What is that formula?
Ma'am, if you have to only find the slope, then y2 minus y1 upon x2 minus x1.
Exactly. So here minus 1, minus 2. So it should be 1 by minus 3. So minus 1 by 3 is the answer. We just are simply finding the slope, right? So it should be minus 1 by 3 in this case. Is that fine?
Okay, ma'am. Yes.
Just the 2-point formula slope we are applying. Slope of the line connecting these 2 points.
So, ma'am, to do these kinds of questions, whatever the differentiation, that value they are asking, I think that only they would have defined at the beginning, like it's a differentiable at x equal to 2, they've given here. And that only they are asking, so we have to just find the slope of tangent.
Yes. See, what is the information given to you? Based on that, you should use the formulas which you know. So if the information is based on tangent, then you should think about what are the formulas you know for finding the derivative using tangent. That's how you need to think. Okay?
Okay, ma'am.
Fine. All right. Okay, so 7th one. Okay, so you are having, yes?
Yeah, this is because I think the questions are shuffled. This is the 7th one we are having now. The comprehensive type question, the company one.
Okay, maybe the numbers are different. Okay, fine.
Well shuffled, I think.
Okay, so f from r to r defined as f of x is equal to x squared and g is defined as g of x is equal to x minus 5. Find the value of f g dash of k minus f composition g dash of k. So composition means defined in this way and product is defined in this way. Okay, so k is some point. Okay, so k we can take to be any integer. So for example, let's take k is equal to 5. You simply have to apply the formula, right? What's the big deal in this? What is fg dash uv dash whole formula? What's that? Fg dash of x is f dash of x into g of x plus f of x into g dash of x. Now what about the how do you apply chain formula for composition of functions? Can anyone tell? How do you apply chain rule? F dash of no one remembers.
F dash of gx and g dash of x.
You simply have to apply this formula with k is equal to 5 or x is equal to 5. What's the big deal in this? This is very clear, right? Obvious one. Just applying formulas. Should I do this completely? No, right? A very straightforward one. Is that fine?
Yes, ma'am, we'll try.
Because you are simply going to apply f of x means you have x squared. So f dash of x you will find which is 2x. And then you have g of x. So you will find g dash of x which is simply 1. And then you have to substitute x is equal to 5 and substitute it in this formula here. That's all. Got it? Okay.
Yes, ma'am.
I recommend you to try this yourself because I have given almost all the basic steps. You just have to plug in the values here and substitute. Okay. Fine. So should we look at the comprehensive type question? Do you want me to do this?
Ma'am, if time permits, then yes, it will be help to understand.
All right. Okay. So let's look at this comprehensive question here. Okay. So the profit of company A with respect to time in months is given by the function f of t in lakhs. So you have some function here. Okay. Looks complicated, right? Or some may even find it scary, right? So if I were you, I would have got scared, right? Okay.
Yes, ma'am. Yes, ma'am.
Okay, fine. Okay. So the profit of company B with respect to time is given by G of t in lakhs again. Okay. You again have some piecewise function. Okay. So we are having two piecewise functions. Okay. So now if the function f of t and g of t denote the profits of the company A and B respectively and are known to be continuous at t equal to 3, then which of the following options are true? So continuity at t equal to 3 guarantees that the left hand limit and right hand limit exist and are continuous and are equal, right? So that is the main thing we have to keep in mind. Okay, so this means that we need to find the limit of both of these functions as t goes to 3, right? So this is the thing we need to do. Okay, so how are we going to do? So just a usual way of finding limits only. So let's see how to find the limit of x goes to, so if you are finding the right hand limit, which function you should apply?
Lower function.
Yes.
Lower function of t.
So f of t means we are looking at limit t goes to 3 from the right. So from the right, what happens to this function? Can you tell? From the right, what
Right,
happens
it
to this
always
function?
stays 3.
3.
It will become 3.
It will become 3, right? So because you will have, okay, this is 1 2 and 3 means, so here you will be having 3, right? So here you are having 3, so you will have all the values coming to 3 from the right. Okay, so here also 1 2 3. Okay, fine. So this is very straightforward. What about the left limit? Limit t goes to 3 minus f of t equal to limit t goes to 3 minus, now this function t minus 2 whole power n minus 1 by t minus 3. Okay, how to go about this? So we'll do step by step only. So here you see that if you are applying 3 for t, what is this value?
1 raised to
One.
n.
Becomes 1.
So 1
1.
raised to the n is again
It's 1.
1. So the numerator is actually becoming 0. Denominator, when you apply t equal to 3,
0.
Again 0.
so you have
Becomes
an
0 by 0.
yeah, indeterminate form is coming. So again we need to apply L'Hopital.
L'Hopital 0.
Yes, so you need to differentiate the numerator and denominator. So if you differentiate the numerator, what will you get? N times of t minus 2 per n minus 1. This part will become 0 and the denominator will simply become 1. Okay, now let's apply 3 here. If you apply 3, what will you get? Yeah, again 3 minus 2 power n minus 1. What is this?
N.
Simply n, because this is 1. So 1 raised to the power of anything is simply 1 only. So we are getting n. So we are given that f is continuous at 3. So left hand limit and right hand limit should be equal. So what is the value of n?
3, ma'am.
3.
2, 3.
Okay. So it is not that scary, right? Okay, fine. So
Yes,
let's look at this
Yes,
problem.
ma'am, the way you are doing it's not scary, otherwise it is.
Yes.
Everything seems like a devil's sums.
Yeah, practice. helps us, right? Step by step. Also, we need to go step by step.
Ma'am, if we cover PYQs of past 4 years means it will be okay to score a good marks.
I have not made a research like that. So you make a research, maybe
No,
you do a trial like that and let us know the result after the quiz.
no,
Okay?
ma'am. In 12th standard, they say that if you study past 4 years, 5 years previous PYQs means you can score more than 75%. That's what I am asking. It's applicable for here also.
See, I can tell you one thing. If you are covering all the GA, PA, AQ, and everything, that guarantees some percentage, and PYQs also helps in some percentage. But that does not guarantee like 100% definitely. But what is the exact percentage it is covering? That I am also not sure. But yeah, it will help you to score a good mark definitely. If you are covering all GA, PA, AQ, and also some PYQs, it will definitely help you score good marks. Okay, you will
Yes, ma'am.
definitely not score something very less than 50 or something and all. I hope that you will get a decent marks, because from this itself, even if you are not able to cover all the PYQs, once you are solving up to this much, you will get an idea of how to approach a problem. That will help you to solve. Even if you are given very new problem, you will have a idea of how to approach a problem, right? So practice helps you.
What's GA, PA, and AQ?
Graded assignment, practice, and activity questions.
Okay. All right. Thanks.
All right, so let's do the next part. So the same thing we are going to do, just like we did for F, we will now do for G. Okay, so now limit t goes to 3 plus g of t. What is this? What is this?
3t raised to m.
Yeah, so you will have 3 t power m. So limit t goes to 3 plus 3 t power m. Okay, now how are we going to do this? 3 is just a constant, so you can keep it out, and you will have limit t goes to 3 plus t power m. So what will you have?
Ma'am, 3 to power m.
Yes, it will be simply
3 into 3 to power m.
So it is 3 power m plus 1.
M plus 1.
Yes, ma'am.
Now let's do the other limit. So t going to 3 minus g of t. So limit t goes to 3 minus t cube minus 3 cube by t minus 3. So when you apply 3 to the numerator, what is that it is approaching?
0.
0. It's the same for denominator also. So what is that we need to do?
L'Hopital?
Yes. So
Ma'am, excuse me,
yes.
ma'am.
Yes,
Ma'am,
yes.
why we are not
Then
applying
it's
the
not
standard
necessary.
limit
We
in
can simply use a cube minus b cube form.
Yes, yes, that also can be done. You can apply a cube minus b cube formula, a minus b. You can do, and then remaining a square plus ab plus b square. Yes, you can do that as well. Okay. See, for that is the advantage of math, right? There is no fixed solution for a given problem. You can have several different routes to find solution. Only objective is the final solution should be same. Okay. So yes, a cube minus b cube, simultaneously you try it and see whether the answer is matching with mine. So here, if I am applying L'Hopital, it will be 3t square.
Excuse me, ma'am.
Yes.
Ma'am, why we are
And
not
aim is
applying
coming
the
2.
Yeah.
Ma'am, I got aim is equal to 2.
M is equal to 2. Let's see. But someone else was asking some question, I guess. What's that?
Ma'am, I was asking that why we are not using the standard limiter in such cases.
Which standard limit? I don't understand.
Ma'am, like for this, the direct answer will be 3 into 3 to the power 3 minus 1.
Where?
Like t to the power 3 minus 3 to the power 3 upon t minus 3.
Yeah.
It is a standard limit, no?
It is a what?
A standard limit.
What do you mean by standard limit? I don't understand. Like
Ma'am,
you
like
are
sin
saying
x by
these
sin
are some
x.
standard
Like
formulas you are applying, you are saying, right?
Yes, ma'am, like sin x by x.
Yes. You can use. Definitely you can use. Okay, so if you know that standard formula, the problem is that whether everyone finds it as a standard formula or not, I am not sure. So I'm just doing all the steps here.
Okay,
Okay. If you find it straightforward, yeah, you can do that. Okay, so here you see that 3 power m plus 1 is equal to 27. So this means your m plus 1 is equal to 3. So m is equal to 2. Okay, so we got n is equal to 3 and m is equal to 2. Is that fine? Yeah?
Yes.
Yep.
Okay. All right. So this part we have already done. So it's not going to be that difficult. Assuming g to be continuous at t equal to 3, choose the set of correct options. So limit t goes to 3 plus g of t minus g of 3 by t minus 3 is equal to 18. So can you quickly, I guess this part should be very similar to what we did here, right? So if it is 3 plus, then we need to apply 3 into t power m here, and g of 3 again the
Ma'am,
same. Yes.
can we do just one option? Can we
Yes.
just do properly one option and rest we will just able to do?
All right, then we'll do just one. So here you see that for 3 plus means you need to apply this part, 3 into t power m. This part we need to apply. So if we are applying that particular part for 3 plus, then you will get limit t goes to 3 plus g of t is, what is g of t? I'm forgetting this term. 3 into t power 2, 3t square. 3t square minus, what is g of 3?
Ma'am, g of 3 will come 27.
Yes. Right. Now again, what's the formula we need to apply?
I
What's
think
the
again
formula?
we need to L'Hopital rule again.
Yes. So if we apply, we will get,
It's a 6t by 1.
Yeah. So which is simply 18. Clear? Okay. So the same way you
Yes,
can do
ma'am.
for 3 minus also. So you have to see whether 3 minus and 3 plus are same. So if they are same, then you know that it is differentiable. If they are different, they are not differentiable. Here you can see that the minus value you should get 9 and they are not equal. Hence it is not differentiable at t equal to 3. Is that fine?
Okay. Yes, ma'am. Yes, ma'am. Thank you.
Okay. Okay, there is one more part. This is about best approximation. So, see, the names are different. Differentiability, tangent, best approximation. They are like different names given to the same thing. Okay, so they are not at all different. They are the same thing only. So here you see you are asked to find. You are given that this is the best approximation of the function at the point t is equal to 1. We are assuming that f is continuous at t equal to 3. Find the value of LF of k. So what is that we need to do? Can anyone think? So if it is continuous at 3, what is the information we know about f? We know that n is equal to 3, right? So if it is continuous at t equal to 3, we know that n is equal to 3. So we know that f of t is equal to t minus 2 power 3 minus 1 by t minus 3. Okay. So now if you know that this is your f of t, then what is the formula for LF of t? F dash of
T into
t minus 1 plus f of 1, right? So how can you do this? You have to find what is f dash of t and substitute 1 and solve for it. Should we do all the steps here, or you want to give it a try? You have to use u by v formula here. What is the derivative of u by v?
V du by dx minus u dv by dx the whole divided by v square.
Okay, so you apply this formula and compute what is f dash of t. Okay?
Excuse me, ma'am.
Yes.
Ma'am,
Yes.
Ma'am, how you get LFT?
That's the formula. So if you don't
differentiated f of t.
LF at a, the formula is this always f dash of a x minus a plus f of a. This is the formula. Okay, I guess I have
what's the meaning of that L?
N.
L.
Linear approximation.
Okay.
Okay, I guess I have added some of these basic definitions and formulas at the beginning of the other PDF which I started with. Yeah, here you can see that the formula is there. Okay, fine.
Okay, ma'am.
Ma'am, I had a doubt from the graded assignments.
Okay, so before that, let me just ask whether everyone can do the remaining part of this yourself, right? You can complete it, right?
Yes.
Okay. So,
ma'am,
yes.
Ma'am, I am not very sure if I'll be able to differentiate this function. So if you take us through the steps for this one, then it will be a great help.
Who is talking? Meghna, right? So Meghna
Yes,
is going
ma'am.
to tell the answer because you said you are not sure, so you can easily tell the answer. So here you see that this part is u. Okay, this
Yes,
part
ma'am.
is u. This part
Yes.
is v. Substitute in this formula. So I'm going to write v first. What is v?
T minus 3.
Okay. So next u is this. I want to differentiate u. What is u dash?
Ma'am, 3 times t minus 2 to the power 2.
Okay.
And then this multiply 1. That's all.
Multiply 1. So this is 0, right? This part becomes
Yes.
0. Yeah. Okay. Minus
Okay.
t minus 2 cube minus 1. This is u. What is v dash? What is v dash?
1 only, ma'am.
Right? And v square is t minus 3 whole square. Right? So now just simplification is left. Right? So if I am going to do some simplification, then you have 3 times of t minus 3 into t square minus 4t plus 2 minus, you have to apply the formula for a minus b whole cube. T cube minus 8 plus 3 or 6 t square minus 6 or minus am I doing it the correct way? This is 2t square and this is 6t. Is that correct?
Yes, ma'am.
A cube minus b cube formula I am confusing here. What is the correct answer here?
Ma'am, plus 60 minus 6.
Okay. So what should be the final answer? What should be the final answer?
Ma'am, plus 60 minus 12.
Okay, so here maybe if you find it incomplete, here you should actually get minus 3a square b. So you should get minus 6t square, and then you should have plus.
And then ma'am, minus 40 is left.
here 12t. This is the first part, right? And then minus 1. Correct? So, and then you have to simplify this term, whole term. So, the numerator is 3 times of t cube minus 3t square minus 4t square plus 12t, and then here plus 2t minus 6 minus t cube minus 8 minus, or minus 8 I can make it as minus 9, 6t square plus 12t. Now you have to do some simplifications. So if you do the simplification, what is the numerator you are getting? Did anyone complete this one? It's just lot of calculations. Plus 9 plus 6 t square minus 12t whole divided by t minus 3 whole square. So what is that you are getting when you simplify? 2t cube, and for t square the coefficient is minus 3 minus 12 minus 15t square, and for t you should have minus 6 plus 30t minus 9. Is that correct? How many of you got this expression? So this is f dash of t. So if this is f dash of t, what is f dash of 1? 2 minus 15 plus 30 minus 9 by 4. 2 square 4, right? So you have 15, 17. So 70, this is 15, 17, 17 minus 9. Is that fine?
Yes,
Yeah.
ma'am.
Yes, ma'am.
Okay. So this is f dash of 1, right? Okay, so the remaining part is you need to look at LF of k. So k is either 1 or 2. So if you are finding LF of 1, then this is what you need to do. You are finding this value is now f dash of 1 is 2, and then you have to substitute it here and complete this. That's all.
Yes, ma'am. Thank you.
Okay, so here this is like lot of calculation, so I recommend you to verify the steps because I may have done some mistake, so I will say that please verify. Okay, it's possible that there are some mistakes. I don't have the correct solution for this, so please verify. Okay.
Okay.
All right, so what's the next question?
Well, in graded assignment, in the very last question, there's a term mentioned maximum. I mean, we have not been taught that in this, like, in the sessions.
Which question?
The last question, right? Like, okay, wait, let me be specific. Question 20.
This one? LED.
Yes, ma'am, yes, ma'am.
Okay. See, this has nothing to do with finding maximum of a function or something. Okay. So here they are saying your x can be maximum 400. So your g should take which value? If x is maximum 400, your g should take which function? The first one or second one?
First one.
That's all. Okay. The
Oh.
maximum has nothing to do with maximum of a function or something here.
Okay.
Okay, this is the problem with our mindset, right? I'm not saying it as a fault. This happens to me also when I was a student, right? So our mindset is that if there is a big problem, like words, lot of words are there, and you see some words which you think are complicated, our mind thinks that the
No,
problem is something we cannot
actually,
do.
I just saw the word maximum. I
That's
didn't
what
read
I'm
any
saying.
of the other question.
Exactly, that's what I'm saying. You see, there are some criterias which our mind thinks that it is difficult for us, we cannot do that, so we don't even try to understand what's going on, right? So I understand what you're doing, but even then, if you think that it is not done, you first go through it and see what is given.
No,
So
now I
not
can
just
do
for
it.
this problem, in general, I'm just giving it as a suggestion. Okay.
Ma'am, can you tell just in general what should be the approach to solve this question?
This question,
Yes,
Remember,
ma'am.
at the end, it's written like maximize profit.
see, in order to sell, maximize profit, don't worry about the word maximize again. See, what we are given, you should understand that, and what you are asked to do, you should try to do that. That's all. See, basically what is usually done, suppose let us say I am prepared, just some pen I am taking. Okay, so led bulb itself I am taking. Led bulb, suppose I am manufacturing each bulb at 10 rupees cost. Okay, 10 rupees cost I am manufacturing, and I am selling it at 20 rupees. Okay, so then what will you do, how will you calculate the profit? So you will see how many pens I have sold. Yes or no?
Yes, ma'am.
So how many I have sold, and what is the profit I have, what is the profit I have told you, what is the selling price I have told you? 20.
10,
Yeah. See,
20.
suppose let's say selling price, just I am telling, selling price, suppose let's say 20. Okay, manufacturing price is, let's say, 10. Okay, and I am selling, let's say, 5 led bulbs. Then what is the total money I am making by selling, first of all?
10 rupees per piece maybe, and then 50 rupees in total.
So 5 into 20 is the amount I am earning, right? And I am actually spending how much to get this?
50.
50, right? So what is the profit I am getting?
50 rupees.
50. I'm just subtracting this and this. Okay, now in this problem, instead of giving the exact numbers, so I am telling that my price is 10. So instead of giving this, they are giving it as a function to you. Okay, so it means what, you need to plug in the value of x, and with that x you can calculate, just like I calculated 5 into 10. You have to plug in x here and use this function, that's all. And here you are also given what is this 20, that also is given as a function. Instead of numbers, you are given as functions, so you are just going to put x here, that's all. Okay, so I've just given a rough idea of what we usually do. Instead of numbers, it is given as functions. So with this, you try to do this problem. All right.
Yes, ma'am.
Okay. Okay.
Ma'am, in this document only, ma'am, there is one more question where it's written fx equal to some other gx is given.
Is it GA?
Yes, ma'am.
Which problem can you say? I'm just scrolling it. This one?
Yes, ma'am. Number 7. Yes, ma'am. Ma'am, what should be approach here?
See, here this is basically chain rule only. You just have to apply chain rule, then you will get it. So here this is composition of functions property you are using here. So this is another function, let's call it h of x. Okay, so you are having g of h of x. So how will you calculate the derivative of g dash of h of x? What is the formula? Do you know or not? That is what we are doing here. What is the formula for the derivative of this? You apply it and do that for LHS and RHS. Use the given values, you will get it. Okay. Okay. Any other questions?
Ma'am,
Yes.
ma'am, in the question where you discussed that limit of x tends to 0, x by tan inverse x is 1, can we not evaluate that limit using L'Hopital's rule?
Okay, so if you want to use L'Hopital, then you should apply the formula of tan inverse, derivative of tan inverse of x. First of all, when we can apply L'Hopital, we can apply L'Hopital when we have indeterminate form. Okay, so first here we have to check whether we are getting indeterminate form. So as x goes to 0, what happens to tan inverse of 0?
It also goes to 0.
Okay, so now you are saying that it is in the 0 by 0 form. So if it is in the 0 by 0 form, what is the derivative of tan inverse of x?
1 upon 1 plus x square.
Okay, so if you use 1 upon 1 plus x squared, are you getting the same answer?
Yes.
Yes, that's all. It does not matter which formula you are using, as long as you are using the proper technique and getting a same answer, that is completely fine. Okay.
Ma'am, but using L'Hopital's rule, the answer is coming different.
How? Just now we saw that it is the same, right?
Ma'am, it's 1 upon 1 plus x squared. Now, then how can we apply L'Hopital's?
When x goes to 0, what happens then?
Like it will be x goes to 0, the numerator becomes 0, but since in the denominator is
Why?
1 upon 1 plus x square, the 1 plus x square will come in the numerator side now.
Yes, but there is a 1 again on the top, right?
No, there's now a 1 in the denominator.
See, what you are saying is that you are saying tan inverse of x, the
Now I'm
derivative.
saying the entire function, like x by tan inverse of 2x.
Okay, hold on. Let's see. Okay, so you are saying we are applying the L'Hopital rule for this function.
Yeah,
So
if I
yeah,
like break tan inverse x in algebraic terms.
yes. So what is the derivative of this? 1 by 1 plus?
Yeah.
1 plus 1 x square.
1 plus x square.
Yes. Now as x goes to 0, what happens to this part?
It goes to 1.
So what's the problem?
Ma'am,
No, I
here
was
it's
saying if
the
we
denominator is also 1, right? What's the problem here? Okay.
That's what I said.
So here there is a 2 here that you should keep in mind. So when you are doing the finding the derivative, so that 2 we have to multiply here. So that you should take care. Okay, 2x the whole square will come. So we also have to apply the chain rule because we are having 2x. So you will get a 2 here. So you will get 1 by 2. Okay. Fine.
Yes.
Okay, ma'am.
Okay, fine. Okay, so any other questions?
Ma'am, 2 more questions are there in chat box. They are interesting.
Ma'am, if it comes 2, then the answer changes now.
It's 1 by 2 again, right?
You are
Here
not
it is 2,
derivative
the numerator is 1.
2x.
The numerator is 1, the denominator is 2.
Yes.
Right? Because here tan inverse of 2x is there.
Yeah.
Okay. Fine. Okay, so let me look at the chat box. So many messages are there. So which one I have to look? I don't know. Okay, so a into sine mod x, b into e power mod x is differentiable at x is equal to 0 if and only if. Okay, is this a PYQ?
Yes, ma'am.
Okay. Okay, what are the other questions?
Ma'am, one which is just now pasted by somebody.
Okay. It's too small. Let me try to zoom it. I'm not able to read it. Hold on. Okay, so f of x equal to sine 17x plus a sine x by 15. This is the exact same similar model, right? You are given that a function is continuous at x is equal to 0. So you find the left hand
0
limit
by
and
0
right hand
power.
limit at x is equal to 0, equate them. while equating you will be finding A and B.
But
Right?
ma'am, what about this 17x?
Yes,
The
ma'am,
number.
please do. Ma'am, please do this once.
Okay, fine. So let's do this. If it is already in AQ, I will directly do this in AQ page itself. Otherwise, I have to write it here. Is it there in AQ or PA or something? Don't make me solve GA. I'm not aware what is exactly there in GA. And
Ma'am, this is
Ma'am,
a
it's most
PYQ.
probably.
Ma'am, this is PYQ question.
all right.
It is in GA also.
That's why I'm
No,
asking.
ma'am. In J,
Ma'am,
it
then
has
do GA, ma'am.
See,
It will
this
be,
is
it will
there.
be,
Hey, are you
ma'am, if
trying
you do,
to pull me? No. This is
No,
there in
ma'am.
GA.
In J, it has different values.
But it does not matter, right? If I'm solving this, you will be able to solve this also, right?
Yes, ma'am,
ma'am,
please solve anyone.
ma'am,
Ma'am,
please,
anyone.
ma'am, please.
Actually, the
Ma'am, at
questions
least,
like differs from person to person in terms of values. The material remains the same, but the value changes.
You see, okay,
ma'am,
fine.
if you do that, it will be helpful to score at least a few marks in GA.
I'm very clearly feeling
Ma'am,
that you are trying to fool me. Okay.
ma'am, you can just
I'm
say
not
that
like that, ma'am.
Okay,
ma'am,
let
like
me do one thing. Hold on. Let me not keep on discussing like this. Let me do one thing. I will tell you what are the basic steps. Then we will skip the calculation part. Okay.
this can be done by L'Hopital, no?
Exactly. That is all we need to see. See, when you are looking at the left hand limit and right hand limit, here we are just looking at actually the limit of this function as x goes to 0. Right? So one thing we have to remember is that if the function is continuous, then you know that f of 0 is same as limit x goes to 0 f of x. Now f of 0 is given to us as b. So now our b is going to be the limit of this function which we are calculating. Okay, the limit is the value of this function. All right, so here you see that this function, here you are having something in the numerator and something in the denominator. So here in the numerator you are having sine ax plus a sine x. So what happens as x goes to 0 for sine ax?
It will goes to 0, ma'am.
What about sine x?
Again, it will goes to 0.
What about the denominator?
It will also go to 0. Then it will become 0 by 0. We should do L'Hopital's rule again.
Yes, so you apply L'Hopital. L'Hopital, if you
How to apply,
apply,
ma'am?
L'Hopital means what is that? You have to differentiate the numerator and denominator. So what is the derivative of sine ax?
Cos A.
And
Cos ax?
Cos ax into a.
A, right? So a cos ax. And what is the derivative of sine x?
A cos x.
Right? See, you are giving me the answer. There is nothing I have to do. Then the denominator is 3bx square, right?
3bx square.
Yes, that's all. And now you have a cos ax plus a cos x by 3bx square. Then what
Ma'am,
is
one
the...
doubt, ma'am. Again,
Yes.
if we apply 0 in x means, it will be like again, like it will be something infinity, na?
See, okay. If you are putting x
0.
is equal to 0 here, as x goes to 0, cos goes to
1.
and here cos again goes to
1.
So this is some number and the denominator goes to 0. This is not an indeterminate form, so L'Hopital cannot be applied again. Okay?
Ma'am,
L'Hopital...
one doubt, ma'am.
Yes.
If any number divided by 0, we get to some like we consider it as infinity, right?
That is the hint here. Exactly what you are saying is perfectly correct. So what is the concept behind what you are telling? When you have some constant in the numerator or some number, okay, in the numerator, and the denominator, if it is going to 0, what will happen to the whole number? That will
It
go
becomes
to
infinity.
Exactly. So it means now we know that this is not going to infinity. If this is not going to infinity, then what you know about the numerator?
It is a number, ma'am. If it's not going to an infinite limits, the numerator will be a number. Maybe it's irrational, rational.
No. Hold on. See, if it is any number,
The denominator is divisible like with some number of the numerator,
Hold
some
on,
factor
hold
of the
on.
numerator.
Let me repeat my statement. Then you will think. See, you are exactly said the same statement. I'm repeating it so that you will get the key point. Let's say you are having some number k here, okay, and you are having x square here. Now, as x goes to 0, what will happen to this number?
It goes to infinity, ma'am.
Yes, but it should not go to infinity because this is a continuous function. So,
Ma'am, because it's not equal to 0, right? They just given statement.
see, that is different. See, hold on. This limit exists. So, if this limit exists, the point is here. The k should go to which number? Then this will not go to infinity. If the k also goes to
K goes to x cube.
if k goes to 0, then you cannot fix what is x cube, x
No,
power 4.
K-
You cannot figure. If k goes to 0, then what happens to the whole term?
Again, it become undefined. Like we should
Then the limit
apply
will
LHS.
exist first of all. It is not 0 by 0 form, but first of all, the limit is going to exist. Because if this k is something which is not going to 0, then you know that the limit is first of all not going to exist. So for the limit to exist, what is the only criteria which can help us from making it not making it infinity? The k should first of all go to 0. Only then this limit will exist. Otherwise, the denominator part is going to 0, which is going to blow up the whole term here. Okay?
Ma'am, what should be the value of K, ma'am? I'm still confused.
See, the value of k is not given to you exactly, but the idea is that unless k is
The
going
value
to
of k
0,
is supposed
this
to be
value
0.
will blow up to infinity. Okay? So this means we should have that this particular part should go to 0. Okay? So that is the hint for you. If this goes to 0, the numerator goes to 0. From that, how will you find a? I cannot say more than this. Okay? Try it.
Ma'am, please, ma'am.
I have given the maximum hint. That's all. There is nothing more than this. When will the numerator go to 0? Just think about it. Okay? So when will the numerator go to 0? If the numerator goes to 0, what happens to the terms here? Okay? So just think about it. You will find the answer. Okay, you have given me the answer. I have not given much, but I've just explained whatever you have told, the same I have explained to you. Okay, just think about it. If you still cannot understand it, we have the revision sessions, we can discuss.
Ma'am, is the answer is A?
That is what you need to find. What is A you need to find, okay?
Oh.
All right.
It's head-breaking, ma'am.
Okay, it's not that difficult. As I told you, in the first glance, it may look complicated, but it is not that complicated. All right. So if you have any final question,
Ma'am, I'm still not like convinced with the maximize profit part.
Okay, so here you see that maximize profit in the, where is that question?
Is the last one.
See, this is in the case that here you are assuming that maximum of 400. So this part just tells you that you are going to use g of x is this.
Yeah, that part is clear. The last one, maximize profit is.
The number of LEDs the company should produce and sell. Okay, what is the value of x for which you are going to get this answer you are saying? First of all, I recommend you to try these steps and see what is that you are getting and what is that you don't know in this part. Okay.
Ma'am, see, the function is given fx equals to 1000 minus x, and that is like the profit. But it is the question wants to know that what will be the value of x so that I get the maximized profit. The only way I know is the maximum minima concept.
So how will you use the maximum minima concept once
That's
you
the
have,
thing, we
you are
can't.
having the function here? Do you know how to find the derivative?
Yes.
Okay, so if you know to find the derivative, then how do you find the maximum value?
We double derivative it and check whether it is greater than or less than 0. If it's less than 0, then it will have a maximum at the cardinal point of fx.
See,
Yes,
Ma'am,
Kashmir,
it's
you are
sorry.
telling, making me
ma'am,
to
a
tell
small
the
doubt,
answer.
ma'am.
Okay, okay. Let me
Ma'am,
just give you a
small doubt,
basic
ma'am, in
thing.
this case.
Okay, let
Ma'am,
me just.
finding, ma'am, one small doubt, ma'am. In this case, finding maximum minimum is like same as what we find in the week 2 and week 3, like minus b by a, finding the coordinates and finding the value of
Exactly. Okay. See, what you will be getting here is something like a parabola. For a parabola, how will you find the maximum?
finding derivative of x and just placing the value of x in the origin function and finding the value of y.
Okay, so please try that. That's why I'm saying you know the
I
answer
can't
alone.
see any parabola, ma'am.
F of x into g of x.
Oh,
That's why I'm saying here I have multiplied a number.
Ma'am,
Here you have a
ask question
function.
to answer, ma'am.
Here, this you have some x here. I'm telling again and again. I cannot do the entire problem here. Come on.
okay,
Okay,
ma'am,
try this.
sorry. Yes.
Ma'am, what is it? The answer is correct, ah?
I have not done anything. Why are you asking the
Oh.
answer is correct? Okay, you
Ma'am, if
try
it's
and do
correct
it.
means I
Okay?
just score.
Fine. See, you are all knowing the answer. It's just that you have to put them up and try it. Okay? Very
Yes,
good.
ma'am.
You are all trying very well. Keep it up. We'll see in some other session again. Thank you all.
Yes, ma'am. Thank you, ma'am. Bye, ma'am.
Bye.
Good night, ma'am.
Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you.